Okay, so let's solve this question. The question states that consider the following two languages over the alphabet. This thing is given as our alphabet for this question, where m and n are natural numbers. That is, m comma n is going to have values from the set of 1 2 3 dot 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 till infinity, right? This is the kind of values that m and n can have. Which one of the following is the correct option, right? We have to select any one of these. So this is a MCQ type question, right? And we have to select only one option, which is going to be the correct one, right? So let's see what the options are talking about. The options are saying that L1 and L2 are context free languages. L1 is context free, L2 is not context free. L1 is not context free and L2 is context free. Neither L1 nor L2 are context free languages. So then the whole of the options are basically stating to us what is context free language, right? They're talking about context free languages, and context free languages are nothing but your regular languages generation mechanism plus a stack, right? Because regular languages are generated by finite automatons, right? Finite automatons, basically these state changing kind of machines, which are where transitions are defined by a set of alphabet, right? These kind of machines accept your strings. Now these strings don't have memory. The only memory they possess is the current state that they have. So this capacity of finite automaton is limited, so a stack was added to it, and the resulting mechanism is basically a push down automaton. And a push down automaton is a machine that accepts your context free languages, right? Context free languages. That is the funda of context free languages. Now these kinds of strings that we can basically analyze it from the left side, the way these strings are going to be read by our push down automaton, and then try to see if we can save certain information in our stack and then extract that information meaningfully and then do this. Basically accept the whole of the string, right? So if we can do that, then we can say that yes, this is a context free language, and if we are not able to do it, then we are going to think that yes, it is not going to be context free language, right? That is the basic thing that we have to do with this kind of question, right? So over here we are given am, right? Okay, is this m over here used again? Yeah, over here this m is used again, so we have to somehow save this information regarding m, right? And states cannot store arbitrarily increasing. This m can stay till infinity, right? So your state information that the finite automaton provides does not have the capacity to save arbitrarily big natural numbers, right? M over here is an arbitrarily big natural number, so states cannot save it. So this must be saved in your stack, right? And stack cannot store numbers, no. So stack must save some kind of a symbol that corresponds to this a, so it can have m symbols for this a, and then those m symbols have to be reduced for b, right? And after that, this c would have this is a very important part. C would have number of c's present in this kind of string is going to be greater than m, because n is greater than equal to 1, right? So we have to still, after b has been done, we still have to keep information regarding the size of m, right, for us to be able to accept or reject, basically judge the kind of string that we are given. Let me express that in a better manner, because I think that maybe you will not be able to follow this right now. Let's make it more visual so that you can understand. So concept is simple, but obviously you must play around with the concept. Active experimentation with the ideas that are presented to you is the key to gaining confidence with those ideas, right? So basically interpreting the string from the left hand side, and you have a stack with you, right? So in the stack, for every a that is present over here, let's say this kind of pattern is there, right? C can have more than 3, right? 4 C's are possible. So this string is part of your L, right? So for first a were to be interpreted, one a is going to be stored here. Second a is interpreted, another a is stored here. Third a is interpreted, another a is stored here. When first b is interpreted, the first a is popped out. Why are we doing it? So that we can know that number of b's are exactly equal to a. right? So if a second B is interpreted, the second A is going to be popped out. When third B is interpreted, the final A is popped out. So now if there were to be a deviation over here and another B were to be present and there is no A to be popped out from the stack, then we can know for sure that yes, that string with this deviation, this extra B present, would not be part of your L1, right? So that kind of thing is why we are storing the A's in the stack. Once that part is done, then we are interpreting the C's, right? How can we know that the number of C's present over here are greater than M? There is no way to know because we have already ejected the M's over here, right? You may say that why not store twice the number of A's that are present over here in every single entry. If you were to store twice the number of A's, right, that is also going to lead us to the problem that how then are you going to judge the number of B's are equal to the number of A's? It cannot be done, at least not with a single stack, right? This cannot be done with a single stack, and that is why this string is cannot be accepted by a push down automaton, right? Push down automaton will not be able to judge, right? Will not be able to judge whether strings of this format are if presented to this any PDA, would not be able to judge that are they part of L1 or not, right? Because it is not powerful enough to do that, and will not able to judge. Hence, this is not a context-free language, because a language which is acceptable, which is judgeable by a PDA, is basically a CFL, right? So this is not a CFL. So over here we can directly write not CFL, not CFL. Now let's judge the second one, the second kind of language that has been provided to us. We can judge this, right? So let's judge it. Copy and then paste over here, paste image. Now it is quite like this. Let's start to read it, right? So if we have AM, now is this M used in any part after this? Yes, this AM is used over here, so we have to keep this information. How can we keep this information? By means of a stack. We are storing the number of A's that are present over here. Okay, number of A's are basically stored in this manner. Then B can have any number of B's because that is greater than 1, right? There would be at least 1 B or 2 B or 3 B after that. This is independent, but for every B, is this N, the number of B's used in the future? Yes, it is used, right? That is also used, right? So let's store for every B a single A also, right? These A correspond to your M, and then for every B that came, we are also going to store A only, because we are using it in a cumulative manner over here. That is why I'm storing only A. Why store different kind of symbols, right? So I stored M number of A's and N number of A's, right? Then C, for when C come, I'm going to basically pop out A's corresponding to every C that is present, right? I'm basically doing this, and C are going to be equal to your 5, right? So I'm going to do it like this. Every A, there is going to be a A inside of the stack. What am I doing? This is not very clear. It has to have some length, no? So first 2 A's, I presented 2 A's over here. 3 B's, I presented 3 B's over here, right? Then 3 C's I removed, so like this and then like this. Obviously this happens with one single term at a time, but that will take a lot of more steps. Just I'm expressing it now so you can understand the whole thing, right? So for every single C, 1 A is corresponding. Every single C, 1 A is corresponding, right? Like this. I hope that you're able to understand this, and because you can do that for every possible arrangement over here, as in a general concept that we are able to do this, right? We can perceive patterns, right? So this M and N as numbers, this is only one instantiation, but in general you must be able to follow that it could be done, because for every single, we are going to save A's for this and A's for this, and then pop it for every single C over here, right? Very straightforward. So this thing can be accepted by a PDA, and that is why this is a CFL, right? So so this can be said This is not a CFL, this is a CFL. So which option states that the first one is not a CFL and second is CFL, right? So not is present over here, not is present over here. This basically claims that L1 is a context-free language, L2 is not a context-free language. This is the exact opposite of what is actually present over there. So this is not going to be the answer. These are saying that all of them are context-free and neither of them are context-free. That is not going to be the option, right? This one is saying that L1 is not context-free and L2 is context-free. So this is basically our answer. Pretty straightforward question, right? And I hope that you must have been able to solve it by yourself, and this video only serves a validation for that solution, because believe me man, you want to solve questions by yourself. That is the only way for you to develop the capacity to solve it in the examination, right? Just don't watch other people solve it and not try it yourself at all. You must try it by yourself only, right? This is, if you have tried and then you see a solution, that is a completely different story, because then the solution is going to be retained by your mind better, right? And with that, I will see you in the next one. Hope you have a very good day.